So hello guys, today we are going to discuss permutations and combinations, and I found that this is really confusing topic, so I just tried to cover it, this permutations and combinations. So quickly going on, so what is a permutation? Permutation is basically the arrangement. So let's consider an example that we have five persons or five people. Let me just draw it here. It'll be easy. So let's suppose we have five people, P1, P2, P3, P4, and P5. And we have five chairs, 1, 2, 3, 4, and 5. So since this is an arrangement, so we will be talking about arranging the people every time. So the question is, in how many ways we can make these five people sit on these five chairs? So the number of ways is that on the very first chair, any of the people can come. So it's five ways. Let me write it here. Then on the second chair, one person will be less. We'll have four. Then on third chair, it will be three. Then on fourth chair, it will be two and one. So the permutations or all the ways with which these people can sit on these five chairs, five people, is 5 factorial, which is 120. And why 5 factorial? Because 5, 3, we'll just multiply it. It is 5 into 4 into 3 into 2 into 1. So let's consider another example. So now in place of these five chairs, we have only three chairs. So how many number of ways um, can these five people sit on these three chairs? So on the very first chair, any one of the five person can sit. So it will be five. On the second chair, uh, out of five, one is gone, so four can sit. And on the third chair, it will be three. So the total number of arrangements would be 5 into 4 into 3. So it will be 60. So for permutations, we have this formula as well, that is n factorial by n minus r factorial. So n here is 5, and the number of people or the number of places uh, where we want to make these people sit, or number of possible arrangement, or maybe what we can say, uh, the ways we can make these people sit is r. So r is 3 here. So it will be equal to 5 factorial divided by 2 factorial, because it's n minus r, multiplied by 3 factorial. So it will be equal to 5 into 4 divided by 2 into, means 5 into 4 into 3 factorial divided by 2, because 3 factorial, um, sorry, so 3 factorial cancels out. So it will be 5 into 4 divided by 2 factorial. 2 factorial is 2 again. So it will be equal to 5 into 4, which, oh, sorry, it's my bad. So it's 5, it's n factorial by n minus r factorial. So it will be 5 factorial divided by 5 minus 3, which comes out to be 2 factorial. So it will be 5 into 4 into 3, because 2 factorial and 2 factorial cancels, so this becomes 60. So now this is the permutation, which is arrangement. Now what's the combination? Combination is not arrangement, it's the way we can choose uh, the elements or people. So repetitions is not allowed. For example, just consider an example that we have, so now we are on combination. So for example, we have three fruits, apple, banana, and maybe any orange, right? So in a party, what is the combination in which we can choose the three fruits? Either uh, we can choose apple, banana, or orange, or we can choose banana, apple, and orange, or maybe all the all the six ways we can arrange these fruits. But it's not the arrangement, it's choosing. So if we have three fruits, we can choose all the three fruits at a time in only one way. That is, either we can pick first apple, then we can pick banana, then we can pick orange, or we can pick orange first, then banana and apple. Uh, at the end, we will have only three fruits in our hand, and that's the way combination is. So let us just again try to understand it with the same example. So we have three people. Uh, we have three. In how many ways three persons can be chosen from five persons? And that is now again we have uh, the same five people: P1, P2, P3, P4, and P5, and we have three chairs again. So now we in how many ways three person or three men can be chosen from these five men to sit on these chairs, right? So now it's not arrangement, it's choice. So first way is to choose is P1, P2, and P3. Then another way for choosing these men can be P3, P2, and P1, but in combination these ways are same. So we will only consider them as one. Why? Consider maybe just try to imagine that there are five people standing and we want to choose any of the three to sit on the chair. So either first, second, third comes and sit on the chair, or either third, second, or first comes to sit on the chair, or either second, third, or first. I mean, second can sit on the first chair, first can sit on the second chair, and third can sit on the third chair. It doesn't matter at the end, right? So only the choice of people, person matters. So it's one, two, three, and then one, two, four, and so on. So now the second example is choosing two numbers out of four. So we have four numbers, one, two, three, and four. So in how many ways we can choose only two numbers out of it? Choosing two numbers, right? So one way is 1, 2. Another way is 2, 1, but we'll not consider it because both the numbers are same, right? Either you choose 1, 2 or you choose 2, 1. At the end, both numbers are same. So this we'll not consider. Then we have 1, 3, 1, 4, right? All distinct choices. Then we have 2, 3, uh, 2, 4, and finally 3, 4. So the formula for combination is this one, that is what I have we have seen earlier, n factorial by n minus r factorial. So in this case, n is 4, so it will be 4 factorial by n minus r, which is 2 factorial, multiplied by 2 factorial again. So it will be equal to 4 multiplied by 3 divided by 2, um, which will be equal to 6. So only 6 ways we can choose two numbers out of four numbers, right? So if let's suppose three persons are standing, one wearing blue shirt, one white, and one red shirt, and we say what are the number of ways to choose any two people? Choosing any two people, right? So you can choose red and white or white and red. Both means the same because it's not arrangement, right? They are not arranged specifically. The question about combination is only plucking them out of uh, like the order in which they are given. Once they are plucked out, means they are pulled out, the question ends there. And arrangement means once they are seated on the benches, like they are made to sit on the benches, then question ends there. Answer ends there. So in combination, people are standing in a row. You just pull two people out of it, or maybe n number of people out of it. The question ends there. It's not about arrangement. So that's the basic difference. So let us just consider one more example. What are different number of choices for like what are different number of ways for choosing three numbers out of four? So again, we have these four numbers, one, two, three, four. So what are different choices of choosing three numbers? So one will be one, two, three. Then it will be one, two, four. Then it will be two, three, four, and then it will be one, three, and four. So this can be 4, 3, 1. This can be 3, 4, 1. All same, right? So there are only four choices, so it will be 4 factorial divided by 4 minus 3, which comes out to be 1 factorial multiplied by uh, r factorial, that is 3 factorial. So it will be equal to 4 only. So I hope this clears the basic concept. But yes, permutation and combinations is um, a bit tough topic. You have to think uh, think for it. But just remember that permutation is about arrangement. So whenever a question comes for permutation and combination, don't go directly to this formula. Always try to count it, because if you go to the formula, you'll always get confused. And combination is about choosing out of it. So I hope that this video is helpful. Thanks a lot. Have a good day. Bye bye.